So today we're going to go over how to find the slope and the equation of lines that are parallel to each other. And if you haven't heard really the basic definition for parallel lines, this is it. So we have the title of our notes, we're going to date them, but first let's go over the definition of really what a parallel lines, because there are always at least two, are. Parallel lines, they have to lie on the same coordinate plane. And what we mean by coordinate plane is when you guys graph on that XY, that's a coordinate plane. So they lie on the same coordinate plane. So you're going to graph them on the same XY chart. So it's not like you're going to have like one line here on my coordinate plane and then another line over there. They have to be on the same graph. So they lie on the same coordinate plane, which again is just your XY graph. And they never ever intersect. That means they never cross. Why do they never intersect? Well, there are two main reasons. One is that the distance between the parallel lines is constant, meaning that when I measure the distance between the two lines, it will always be the same. So if they're 3 inches apart here at two random points, they will continue to be 3 inches apart. So because that distance never changes, they never can get closer and closer together. They never intersect just because they're always in equal distance apart. But more importantly to what we're going to use, parallel lines have the exact same slope. That's why they can't intersect. That's why the distance doesn't change. It's because they have the same steepness, the same rate of change, the same slope. So that's why they don't intersect. So how do we use that to our advantage? Well, mostly we will ask you to find the slope of a line parallel to another line. So if we know they have the same slope, which we use M is slope, M1 equals M2. So the slope of my first line must equal the slope of my second line. So for example, if I were asked you to find the slope of a line parallel to y equals 3x plus 2, well, we know that we're in slope-intercept form because that y is by itself. So we can easily find that the slope of the line is right before my x. So I know that the slope here is 3. Now, I don't really care what my y-intercept is because we're just trying to find the slope. So my slope for M1 is 3 over 1. And since my slopes have to be the same for my parallel line, the slope of the line parallel to y equals 3x plus 2 must also be 3 over 1. That's all you do. You just find the slope of your line and say, well, it has to be the same because they're parallel, so here's the slope. So again, it shouldn't be too difficult, it's just having to remember it. So I'm going to erase the board, hit pause if you need to copy more down, but we need all of this in our notes. So let's do some just very basic examples before we make them a little bit more complicated. So because we are asking you to find the slope, so we're going to just do some good old-fashioned examples of finding parallel slopes. And again, remember that in parallel lines, your slopes are equal. So M1 has to equal M2. So you'll either be given an equation in slope-intercept form, maybe in point-slope form, maybe in some random form that we haven't come up with, because there's standard. We can do that too, but we always have to find the slope. So we're going to be nice. We're going to give it to you in point-slope, so you can, slope-intercept, so you can identify the slope pretty easily. So we have y equals 4x plus 2. We know that we're in slope-intercept form. We are in y equals mx plus b. So we can tell you that the slope of my first line of M1 equals 4 over 1. And since my parallel slopes have to be the same, we therefore know that the answer, that the slope of my line parallel to this line has to be the exact same So it's also 4 over 1. We'll do that. So not too bad, right? Okay, let's make it a little bit more difficult. What if I gave you this? This is what we call standard form. It doesn't tell us anything. We don't know the slope. We don't know the intercept. We don't know a point. It just looks really pretty. So we have to solve for something so that we can identify the slope. And the easiest thing to do right now is to solve for y, put it in slope-intercept form to find the slope. So that's what we're going to do, is we're going to change it to y equals mx plus b. So I'm going to solve for my y, which means I'm going to work from my outside in. So I'm going to subtract the 6x. And when I write this, since it's y equals mx plus b, I'm going to put that x first. So negative 6x plus 4. The 2 is bothering the y, so I'm going to divide each term by 2, and I'm going to show that no big lines, only small lines. So y equals negative 3x plus 2. So here's the equation of the first line. We can identify the slope now, because it's in y equals mx plus b. So m1 equals negative 3 over 1. And because parallel lines have the same slope, therefore the slope of my second parallel line, or the line parallel to it, must also be 3 over 1. It really is that simple. Okay, what if we have this? And this is where things kind of get a little ugly. So example number 3. Notice that this only has one variable. We're into one of our special cases that we either have a horizontal line or a vertical line. I'm going to solve for whatever variable I'm given. In this case, it's y, so I get y equals 3. Now remember, whenever we have y equals and there's no x, we know that it's going to intersect our y-axis at 3. So we have a horizontal line. And when we have a horizontal line, what is our slope? Our slope is 0. So therefore, for a horizontal line, the slope of it is 0. So m1 is 0. Therefore, the slope of the line parallel to it must also be 0. Isn't that fun? So remember, whenever it's y equals, it's a horizontal line, and since you can walk on the line, you have a slope of 0. What if I give you something like this? Now we only have x equals. There's no y. So when there's x equals, I'm going to solve for it. I get x equals negative 2. So that means I'm intersecting the x-axis at negative 2. So therefore, it has to be a vertical line. Can you walk on a vertical line? You cannot. It's impossible. So this is when we have a slope of undefined. All vertical lines are undefined. Therefore, the slope of this line of m1 is undefined. So the slope of m2 must also be undefined. Make sense? I hope so. Okay, so hopefully you've just grasped the concept that we always just need to solve for y to get it in slope-intercept to find our slope, or solve for x or y when we have vertical and horizontal lines. For parallel lines, you're just finding the same slope. But what if I want to find a specific parallel line that contains certain points, that, you know, has a y-intercept of 4, or maybe goes through point 42. So that's what we're going to do now. So our last step is finding parallel lines that contain a specified point. So, example number 1. We have point P that is 6, 4, and it is, so our parallel line has point P, which is 6, 4, and it's going to be parallel to this given line. So the directions read, write an equation for a line that is parallel to the given line that passes through the given point. Okay? So, we know that this line, it's very easy to determine the slope. We know that the slope of this line, the M1, is 3 over 1. Therefore, my line that's parallel to it, M2, must also be 3 over 1. If I said 3 over 4 before, I have no idea why. So that's the slope we're going to use. And because we're given a point, we're going to put this in point slope form, which is, as you should recall, y minus y1 equals m times quantity x minus x1. Why should we use point slope form? Because we have the slope and we have the point. So it's fairly obvious that that's going to be the best option. So I'm going to do y minus 4 equals 3 over 1 x minus 6. So now I have found the equation of a line that is parallel to this line but contains 0.64. Okay, let's do one more. I'll keep that equation up. Okay, what if we did 0.0, negative 3, so that's my P, and it is parallel to y equals negative 4 over 3x minus 7. Parallel lines have the same slope. So M1 is negative 4 over 3. That means M2 must also be negative 4 over 3. I have my point, which is x1 and y1, so I'm going to put it in point slope. So I get y minus negative 3, so I know I'm going to have to simplify that, equals negative 4 over 3, x minus 0. I get y plus 3 equals negative 4 over 3, x minus 0. And that is your final answer. The equation of a line that is parallel to this but contains this point is this sucker right here. Any questions? Write them down, circle them. Hopefully it makes sense. Just remember parallel lines have the same slope. So I'll see you tomorrow.